talk about some of the verification challenges. We can say this is our third year of this conference. So I just wanted to review the challenges we've had this year and then put it in context of the full 3 years. So we ran in India earlier this year, and the verification challenges from India are on the screen. A lot of people now, especially at SOC level, as dynamic power becomes more important because of the manufacturing shrinking of our technology, dynamic power becomes a lot more important. A lot of people find that challenges at SOC level. AMS has always been a challenge for people. I think more and more analog is getting onto our chips. People find the real challenges at the interface between the digital and the AMS, between the digital and the analog, especially analog modeling techniques, which allow you to do co-simulation of the digital with that analog model. It seems that analog modeling is still very much an art rather than a science. So not only, every company does it slightly differently, and usually within a company it's based on an individual's expertise to do a model rather than the necessarily guidelines that they follow. I think we've talked about levels of verification that Max Linear mentioned. Laurent, the reason I mentioned safety critical is that a lot of people have to follow a requirements-driven verification flow to meet those safety standards, and they find that to meet safety standards it's more about documentation than verification. And predictability. A lot of people are more after predictability in their timescales as the market pressures shorten our windows where the product becomes useful in the marketplace. Being able to predict when verification is going to finish, so you actually hit the market on time. I think JL has something on his talk as well about, if you don't hit this market window, then it's not worth doing anymore. So if you can't actually get to market on time, then sometimes those products aren't actually worth making. Laurent's already talked about exploiting formal, and system level coherency was talked about as well earlier. So you can start to see some common themes. These are the ones we had across Europe. I won't take so much time on these. But there's another theme there: fewer bugs, earlier bugs. How do we find our bugs earlier? Or even better, how do we make sure they don't get put in the first place? Very much an avoidance theme. Across Europe as well, in Germany and in UK, people are talking about measuring test batch quality. There's a lot of talk about certitude on that front, but also in terms of formal verification, being able to inject faults through mutation analysis into formal verification as well. And Altera gave us some challenges from an FPGA point of view. Complexity is very much a common theme, and finding resources. I think there's probably a worldwide shortage of verification engineers, and so finding resources and using them effectively is always a challenge. You've seen the ones today, and also from Infineon as well in Munich on Monday. Again, ISO 26262 comes back to the safety critical, complying to standards, and as I say, it's more of a documentation exercise than a verification challenge. So over the 3 years, I think we've now had about 55 challenges from probably about 20 different people, representing about 15 different companies, and they're the top 9. I only chose 9 because next one at level 3 there's about 7 challenges. So they're the top 9. So if you'll hopefully recognise a few of those. I was slightly surprised by requirements-driven verification and the standards compliance thing, but it seems that our products are getting more and more, as Laurent hinted, more and more into safety critical areas. And the standards bodies are now, where before they mandated certain levels of software testing to a certain standard, they're now starting to mandate also that our hardware gets verified to a certain standard as well, and also that we can demonstrate that our hardware has been sufficiently verified. And I'll leave that one up before we go to break. That's all the challenges. So there's a lot to read there, so I'll just leave it up whilst we drink our coffee. So thank you very much to our speakers from this morning, Ron, Johan, Essin, and to Mark. And after lunch, after a break, we're back in here for some more user papers from Infineon, from Doulos, and from TBS. Okay, thank you very much.